What's today? Hey, today's my son's 18th birthday, my younger son. No, no, I don't. Did I say I think? Oh, no, today is officially, it's May 15th. Yeah. Whoa. Yikes. You'll find more meat on this bone here today. Those exponent problems that I'm sure you all got done on Thursday were just kind of like, nothing to it. You get rolling and you just cruise right through them. These are a little tougher. Yeah, so I have 8 examples for you. If you feel when I'm done, like, well, I could use some more, I could conjure these up relatively quickly. So these will get more difficult as we go through the 8. So just let me know. Just ask lots of questions. It's nothing too bad. You just got to know what you're doing. So for our first one, so I'm going to try to give you some kind of guidelines as we go. And honestly, as you go through the assignment, you'll develop your own strategies or you'll sort of refine them and master the art. But the idea here is the first thing we want to think, and that you can take this with you for all 8 examples. You can take this with you for the entire assignment. You can take this with you going forward after this year and on into next year, is that you want to get rid of the parentheses. So what happens is, like, the 4 and the X, they're going to play a part in this problem, but they can't right now because they're bound up. So step 1, and I think this was, I know this was in Thursday's assignment, is you have to master the art of essentially distributing a negative, or distributing an exponent, excuse me. So this exponent of 2 is going to apply itself to anyone that's inside the parentheses below him. So the 2 is going to apply himself to the 4. And what is 4 squared? 16, indeed. And then it's also going to apply itself to this X, and X is already to the power of 1. So we just give it, we just give it the power of 2. If something doesn't have an exponent, then just assume that it's 1. Sometimes you don't really need to think that way, but that's that. And then this is all over whatever the bottom was, which in this case is 8x to the 3rd. So that should be step 1, is always get rid of any parentheses by distributing the exponent. And then step 2 is to deal with the 4th grade part of the problem. And that has nothing to do with algebra. That is just cleaning up the numbers. So just like you did back in 4th or 5th grade, you need to reduce these 2 numbers. And again, no properties of exponents or anything. What is 16 and 8 reduced to? Right. And because it's, oops, I didn't mean to use green there. My bird. And because it's 2 over 1, then we want to make sure that we put the 2 on the top of our answer like this. Had the 8 and 16 switched places, then of course the 2 would wind up on bottom, right? Well, so we always say, like, where there was more, there will be more, right? When you reduce a fraction, you just got to think in terms of where the leftovers basically going to be. And at this point now, I'm going to show you a real basic property of exponents, which I feel like it's probably come up, but I just never know. 8th graders, 9th graders, it's kind of different, the past that you've had, your experiences. Does anyone know what you have to do with these x's? Since there's some on top and some on bottom, that's not simplified when there's some of like some in both places. You don't add them, but that's exactly a logical thought, because that's what we were doing last week. But remember, we added them if they were like this. So if we had like x to the 2nd times x to the 3rd, then yes, we would have added 2 plus 3 and gotten x to the 5th. Say that again? Yes. So by the same logic that when there's a multiplication problem, we add the exponents, when it's a division problem like this, we subtract the exponents. And so we're going to take the power of x on top, which is 2, and we're going to subtract the power that's on bottom, which is 3. And what is 2 minus 3? Definitely -1. So what I'm going to do is I'm going to put x to the 1 but I'm going to put it on bottom. Because when I subtracted the exponents, I got a negative, that's where his home will be. And do note that when we put it in, we didn't put it in as x to the -1. By putting it in the bottom, we have taken care of the fact that it would have been negative. And if you struggle to understand why that just happened, well, let me show you what it would have looked like. X squared, you agree, is x times x, right? And x to the third is, of course, x times x times x. So if you ever wonder, like, gosh, why did that happen? That seems really weird. It's not that weird at all, actually. If you cancel out this x, and then you cancel out this x and this x, it seems pretty obvious to me that there's one left over and that he is on the bottom. Again, it goes back to the logic of where there was more, there will be the leftovers. And that's it. That would be our final answer for a problem like this, is just simply 2 over x. Okay. Let's go again. Round 2. On top, we're going to have 6 times m to the third to the third. And on bottom, we're going to have 20 m to the fourth. See if you remember your steps. What's step 1? Get rid of those parentheses. No matter what the case is, you get rid of those parentheses. And in this case, the only thing in the parentheses is an m. And do you guys know or remember what to do with these two exponents? You do. Very good. And that was one of the hardest parts for some of us, was that difference between when do I multiply exponents and when do I add? When it's a power raised up to another power, that's when we multiply. So the top of our fraction is going to be 6. Notice that doesn't change because he didn't have an exponent of 3. So the top is 6m to the 9th. And then, of course, the bottom is going to stay the same. What's step 2? Right. Do the grade school part, right? So don't just look at the 6 and the 20. Forget the m's. Forget this is algebra class. What can 6 and 20 both be divided by? 2. So if there's one thing that I know for absolute sure, it's that my answer is going, not thinking like maybe, it is going to have a 3 and a 10, like that. The only question now is, where is the m? And notice I've just left a little room in my fraction. Maybe it'll go on top, maybe it'll go on bottom. And again, the same property is going to get us through. What do we do with these powers of 9 and 4? And what is 9 minus 4? So where will I put m to the 5? On the top, because 9 minus 4 came out positive. Again, logic. There were 9 m's on top and only 4 on bottom. So when you cancel them out, the 5 leftovers will, of course, be on. Easy peasy? All right, good. Let's get to round 3. I have negative 4x to the power of 8 all over 3x to the negative third to the power of 3. If you are taking notes, it's important that you copy them down as soon as they show up on the board. Otherwise, when I explain the process and we're talking, you're still trying to get caught up. That you miss out then. So stay fast. What do? Good job. So I'm going to leave the top as just negative 4x to the 8th. That's just what it is. And then the bottom, the 3 that's over here on the outside, is unaffected by the exponent, right? Because he's not in the parentheses. What is my x power going to be? Negative 9. Negative 9. Very good. So I'm going to have x to the power of negative 9. And again, we acquired that negative 9 by multiplying the exponents together, right? What's the next step? Simplify the number parts, right? And in a case like this, honestly, I look at it and I think to myself, there's not a lot of meat on that particular bone. the only thing I can say is this negative sign right here, and you can disagree with this, and you should if you want to. That is the only negative sign in this problem. And I get that you might want to say, well, what about that -9 on the bottom? Bless you. That does not count because that's an exponent. So when we talk about like overall like positive negative numbers, the only negative to be found is up in the top. So I'm going to take that negative sign and just assign it to my whole answer like this. And now we don't have to talk about that anymore. Can 3 and 4 be, or 4 and 3 be reduced? No. So I'm certain that my answer is going to have a 4 and a 3. And again, all I've done so far is really pull that negative outside. It's not polite to leave negatives in the top or the bottom of a fraction. We always want to clean them up. And if it's an overall negative, we put it out front. If there happened to be a negative also on the bottom, then we would have canceled them out. But you don't want to leave negatives tucked inside of fractions. That's just not what people do. Now, this always is interesting. So watch out. I have to take the top exponent and subtract the bottom exponent. What's your first thought? It would be 17. And yes, because a lot of times people want to say -1, and that's where I struggle. Like when I taught you slope back in like November, was it's hard to convince people to show their work. It's very quick and easy to just be hasty and say, oh, that's 8, -9, that's -1. It is not. It is 8 minus -9. And of course, then you see it, a minus and a negative touching butts like that become a plus sign, and 8 plus 9 is 17. So we have x to the 17th. Where shall we put him? On the top, because it's positive 17. Final answer. Got it? Okay. But okay, we're 37.5% of the way done with our examples. 3 out of 8. Hey, good. All right. Next one. I have 6x to the -10th over the quantity of -3 x squared to the power of 3. Sorry to ask you this, but I will ask you every time because it's, I think, what we do in this business is we say and do something until it just gets stuck. What do we do first? Get rid of the parentheses. And in this case, there are 2 items inside the parentheses. One of them is a -3. So he is going to become the recipient of that exponent of 3. Can anyone in this room tell me what -3 raised up to the power of 3 might be? It is -27. Nice job, Bryce. It's negative because we're multiplying a negative number by himself 3 times. And it's 27 because, well, we just know 3 to the third is 27. So at this point, I'm going to start rewriting the problem. So on top, I'm still just going to leave my 6x to the -10th. And on bottom, I am now going to start building this. It is -27. And how about this green arrow? What is x to the 2nd to the 3rd? Noise. X to the 6th. That's, again, that rule where I have an exponent already. You feed me another exponent up above. I'm going to multiply those bad boys together. Follow steps. You can't miss them. I mean, in theory. What's the next step? Simplify. Forget x's, and there'll be maybe some y's later on. Just forget all that. Just reduce. So how many negatives do you see in this problem? Just one. Remember, the -10 doesn't count. It's a negative exponent. It doesn't affect anything as far as the sign of my answer. So like I said before, if there's just one negative, which is what this is, then overall, my answer is going to be a negative fraction. Don't leave the negative buried inside. Yes, ma'am. If there had been a negative up here, then the negatives would cancel each other and our answer would not have this negative sign. Does that make sense? All right. Now it's time to reduce the 6 and the 27. What can you divide them both by? 3, which leaves behind no negative, please. The negative has already been taken care of. It's just 9. It's imperative that you filter all negatives out to the front and then call it good. And now it's time to use our rule. And that rule, again, I wish that this were never an issue in high school, but here it goes. Negative 10 is the top. Minus 6 is what? So where shall I put my x to the 16th power? You got it. X to the 16th power. My answers sometimes look a little wonky, like asymmetric, just because of the space that I leave. Because I go into these and I don't know if my extra stuff is going to go up or down. So some people have a little bit of OCD about this, and they would take this to. I'm not one of these people. I don't worry too much about it, but like they might say, I like my 2 better if it's centered like that. But whatever. That's your business. Besides, you're going to put these into delta, so it doesn't care, obviously. Halfway done, still good. All right, round 4. Negative 20, x to the power of 7, all over negative 5, x to the power of negative 3, all raised to the 3. What do we do first? Parentheses. And so you'll find yourself copying things down a lot, which whatever. We're not worried about that. So the top gets copied down, rebuild my fraction. The negative 5 is unaffected by the exponent, so I'll just copy him down. Oops, I had the wrong tool there. There we go. And what is my x going to be? X to the negative 9, because that's a multiplication instance. Trying to be as repetitive so that these steps get just stuck. Because if you follow the steps, it'll just literally always work. Like, that's nice. So this goes back to Kyla's question from like 3 minutes ago. So when we proceed to the next step where it's time to simplify the non-algebra-y part, note, of course, that the top is negative and the bottom is negative. And what does that mean? Yep, it means that I don't ever have to say any negatives anymore. Right, that's nice. So my answer is positive, and I can ignore those yellow negatives, forget them. What do 20 and 5 reduce to? Top 4, bottom 4? Definitely top 4. So I'm going to put 4 up here on top. And again, it's a little off center because I'm still leaving room. I don't really know where my x is going to go. So what is the answer to my x's? It is. And again, that comes from top exponent minus bottom exponent. And you see it. Minus and a negative become a big old plus sign. And 7 plus 9 is 16. Where will my x to the 16th go? So I look at a problem like this and I think there's nothing left on bottom. And that answer just doesn't feel right to me. So rather than do something stupid like put a 1 here, because that's just creepy, what I would do is just write my answer as 4x to the 16th like this. You should never have fractions that have 1 in the bottom unless you have a reason. Like if your math teacher says, hey, what's the slope? And you're like, oh, it's up 4, right 1. Then that makes sense in that context. But generally, people will just think you're weird if you put things over 1. Still good? All right. This will be round 6. I have negative 9 times the quantity of x squared, y to the negative 4th. So we've introduced now multiple variables. But if we follow the steps, we're going to be just fine. All over 6. Oops, wrong tool again. I'm kind of a tool for using the wrong tool. 6x to the 5th. I'll ask my question a little differently this time. ¿Qué tenemos que hacer primero? Yeah, it's always going to be those parentheses. So the -9 on top is going to stay, and the bottom is, ooh, that -9 is a little floaty up there. And then the bottom is going to stay also like this. So let's clean up our exponents or our parentheses. What does that make right there? Nice. And how about green arrow? What's that going to make? Definitely y to the +8th, because we just multiplied the existing exponent by the new exponent. Next step. So we got to consider all the easy stuff, like the negatives. There's only one negative, so it's not going to cancel out. So overall, I look at my answer and say, you're a negative. And we'll get that out of the way. Now, what can 9 and 6 reduce to? 3 and 2. Divide them both by 3. You get 3 and 2. And now it's time to use our skills. For the x's, I need to clean them up because there's some on top and some on bottom. And what is top exponent minus bottom? -4 minus 5 is, so I will put x to the +9th, but I will put it on bottom. Because when it comes out negative, you put it on bottom. When it comes out positive, you put it on top. And then that y is sitting there like, I got nobody to go with, so you can just leave me right where I'm at. So we're going to put y to the 8th up on top. Be done. There is something that might come up that I just thought of that's not in any of my 8 examples. So I'm going to do examples 7 and 8 with you, and then I'm just going to pop something into your notes just in case. And the ones that I clicked through this morning, I didn't see it, but just in case, I don't want to leave you wondering what to do. Or like, hey, why did it mark this wrong? So let's finish up these last 2, and then I'll tell you this might happen to you kind of thing. So next one. 8x to the power of 11 all over the quantity. Oh my God, I did it again. What a dork. The quantity of 4x y to the -2nd all to the power of 3. What do we do? Get rid of those parentheses, right? And there are 3 recipients because they're all in parentheses. So here I go. I got different colors. 3 is first going to apply himself to this 4. And what is that going to become? It is not 12. Four to the 3rd power. It is not. It is not. 4 to the 3rd power is 4 times 4 times 4, which is 64. Good. I shall switch now to Mr. Green Pen. What will x be? X to the 3rd. And now I shall switch to yellow pen. Y will be to the, yeah. And then the top I just have to copy down again. Oh, good. This is actually going to cover what I was going to say. So I didn't, I forgot. Yay. So I don't have to have that little extra thing. Unless you want me to, I could do it again. Say it again. Next step. Yeah, so there is no negative anywhere in this problem, so I know my answer is just going to be positive. I don't have to sweat that. What do 8/64 reduce to? 1 and 8, and again, if it was bottom heavy, it'll stay bottom heavy. So I am going to place a 1 here, and I'm going to place an 8 here. The only way I will leave that 1 is if nothing else goes to the top. If someone else comes up then he'll basically say to the one, like, you can go now, bro. Like your services are not needed. The one right now is holding the place, but you might not need it either. So let's hit our X's. It's looking to me like a pretty third gradey kind of problem here. What is 11 minus 3? So I'm going to put x to the 8th on top, and that spells the end of this 1. You should not leave ones where they don't need to be. It is bad juju. What about that y? So this is what I wanted to tell you. And I've long passed the point where scientists say that kids and humans, mostly young people, stop listening after 20 minutes. It's been like scientifically proven. And I'm about 5 minutes past that, so I hope you're still listening. Are you still with me? You cannot leave negative exponents in your answers. It is not acceptable practice in math. So because this y is just sitting here, let me put a red sort of cloud around him. That is no bueno. So here it goes. When something has a negative exponent, you have to pick it up and move it either upstairs or downstairs, depending on where it is. So like y to the negative 6th can't stay there. So all I'm going to do is wave my magic wand and move the y upstairs. And when I move it, I make its exponent become positive, like magic. That is a property of exponents, and I don't want to spend a whole day like just practicing that. I've made that mistake in the past. It's not that it's not that much to ask you to memorize that. Things cannot have negative exponents. And so if you find yourself at the end of the problem with something with a negative exponent, simply move it up if it's down, or move it down if it's up. And I said it didn't bother me much, but that 8 being off center like that is going to keep me up tonight. So I'm going to move the 8 a little bit more like this. Good, good. All right. Uno más. Oh, gosh, I'm out of whiteboard space. Do you see this? Look, I can't scroll anymore, but that's a good sign that I should be done. So on top, we're going to have -4 times the quantity of x to the -4th, y to the 5th, all of that to the power of -3, all over the quantity of 2x to the 6th, y to the -3rd, all of that raised to the 2nd. Well, since, why break with tradition? Here it goes. What do we do first? Yeah. Can you imagine if you made it this far in the lesson and you still didn't know the answer to that question? Get rid of the parentheses. So on top, I've got a double distributor. So I'm going to take the -3 and I'm first going to distribute it to this x. What's he going to become? X to the 12, right? And the -4 is unaffected because he's not in the parentheses, right? So x goes to the power of +12. And what will my y be? Right. All right. And then on bottom, second verse, same as the first, get rid of the parentheses. There are 3 recipients this time. So what is, ooh, wrong tool again, tool. What is the answer to that? It's just 4, right? That's really important that it's just 4. You got to see that there are 3 separate entities in these parentheses. There's a 2, there's some x's, and there's some y's, and each of them gets smacked independent or individually by that power. So 2 got his smacking and became 2 to the 2th, which is 4. Now it's x's turn. What is x going to be? Yep. And what is y going to be? Good job. I don't think you're going to see any problems where this like 3-step system doesn't work. All right, step one, eliminate parentheses. Step two, do the little kiddie grade school part where you reduce the numbery fractions. And then step three is hammer down your exponents. I mean, it's what it is. You can make these problems really big and nasty with like 5 variables, and it's like, ooh, same process, same steps. So let's talk about just the numbery parts first. First off, overall, is my answer going to be positive or is it going to be negative? It is going to be negative, so I'm going to go ahead and write that down, negative, and then I like to just draw my fraction bar and get it ready to rock and roll. How about my 4 and 4? They basically they just cancel each other out like this. So the only way I'm going to even acknowledge that there's a 1 where they cancel out is if I need him on top. Okay, so if you want to right now, you can put the 1 in there. If you want to kind of have the glue that holds the fraction together, but I'm certainly not going to put a 1 on bottom. Under no circumstances would I ever purposely put a 1 on the bottom. That's just creepy. And that 1 might not be long for this world, so he's just holding it together. Tell me about the x's. Yeah, so where are there any x's in my answer? None? None at all. So there will be no x's. So x to the 12 and x to the 12 are perfect dead. 12 minus 12 is nothing, 0. So x is gone. Okay. And then for the y's, you do have to do, sorry about that, some math. So here it goes. Top exponent, I'm writing it down here in the corner, is negative 15 minus negative 6. And what happens to that minus and that negative? Yeah, these two that are touching butts become a plus sign, like that. And then I just, again, have to hope by the time you hit my Algebra 1 class that you don't mess up stuff like this. What's negative 15 plus 6? Negative 9. So I'm putting in y to the 9th where? On the bottom, because it's negative 9. Good. So the 1 turns out has to stay. He is going to hold the fraction together. What do you think? No, the fact that when we subtracted negative 15 plus 6 and we got negative 9, that's why we put it in the bottom, because it was y to the negative 9th, but by putting it in the bottom, remember, we don't actually put it as negative 9. We put it in the bottom, and that makes it positive 9. That makes sense? Yeah, but it wasn't already anywhere. It was kind of when we're doing this yellow subtraction problem over here, we're kind of in limbo. Like we're waiting to see if we're going to put our answer on the top or the bottom. Like when we put it in, we're going to put it in as a positive. It's a matter of where are we going to put it, right? So it's not anywhere yet. It's just in limbo. Got it? All right, there's an assignment on the old Delta math for you. Let's get it going. I don't expect you to get this one done today. That would be pretty amazing if you do. It's not a challenge. I will pause this in case anyone has one of those questions where I go, oh, I should have said that. So